got it. Oh, staring at me. Okay, so talking about sig figs today, a little bit more. So you had some practice talking about sig figs or looking at sig figs in that virtual lab you just did. When we were talking about sig figs, when doing any measurement in chemistry, it's important that you use the correct precision. Last time I used the example of a bathroom scale that measured out to 68.0389, and I think maybe a 6 on the end, a whole bunch of digits there, right? And when I gave you that example, I said that you probably would assume I used some special scale and not just my bathroom scale. My bathroom scale wouldn't give me all those digits, right? So I either used some special scale or I just made those numbers up, which is what I did. Which means we have to make sure our data is valid. We can't just add extra digits. So when you were looking at the burette or the flask, you can only guess between the markings. You can't say 300.000 milliliters because that's not accurate. That is not what your flask said. It didn't have that much precision. Rather, you could guess about 248 or 258, something like that. You know, those aren't exact numbers that you used, but I think you get the gist of what I'm saying. So all measurements should be made by writing all units you know and then estimating that last digit. So that's what you just had practice doing, estimating right between the lines. We're going to practice doing that just a little bit more here in a second. If you're looking at page 6 with me now, there are some rulers down in the bottom corner. We're going to talk about those. I'll give you just a second. I'm sorry, I'm going too fast. I'll give you a second to write those down. So look at page 6 for a second with me here. We've got our rulers, and on these rulers we have markings every 5 for this first one. I'll show you a line, and I want you to help me measure the length of this line. Here's my line here, and my line ends somewhere between 50 and 55. What would be a good guess for about how long that line is? About 54, maybe about 53, but we're not saying 53.55, correct? That's too precise. We only have markings every 5, so we can guess the digit in between. We could say 54. Or maybe we could say 53, either is fine. I've got another line here, and this line is on a ruler with markings every 5 again. This line looks like it ends somewhere between 35 and 40. What would be a good guess for about how long this line is? 38, 39, 37, something like that. But we're not saying 38.000. We don't have that much precision. We're just guessing between the markings. So I guessed about 38 as well. This ruler down here, we've got markings every 1. So it looks like our line is ending somewhere between 13 and 14, a little bit more precise here. What would you guess this line is? 13.8 or 13.9? But we're not giving any additional digits. We're just guessing between the lines. So I think I said 13.9. That's okay, 13.8, 13.9, that's perfect. Got a few more here. This ruler up top, it looks like it has markings every 0.5. We don't have any units, but it's every 0.5. So 3 and 3.5, somewhere between the two. What do you guys want to guess this line is right here? 3.3, 3.4, something like that. But we're not guessing any additional digits. Very good. Again, we're just guessing between the lines. I guessed about 3.4. We've got another one down here. This one has markings every 0.1. So it looks like we are between 1.1 and 1.2. How would you read this line? Between 1.1 and 1.2. Is it quite 1.2? No, but it's more than 1.1. So we can guess one more digit. Anybody willing to help? Sydney? 1.19. Good. It looks like, between 1.1 and 1.2, we could say 1.19. We could say all the way down between 1.16 and 1.19, right? Somewhere kind of between the two. Do you see that we're guessing that one extra digit? So it's not quite 1.19 or 1.11, but it's not I misspoke. It's not 1.1 and it's not quite 1.2, somewhere between that. I guess 1.16, but anything around that would have been fine. And finally, we've got a line down here on a ruler with markings every 10. So we'll have to guess here between 70 and 80. It's not quite 80, but it's a little more than 70. What do you guys think this one is? 72, 73, something like that would be perfect. Awesome, wonderful. We guessed that one extra digit. So every measurement in chemistry must have a unit. It's really important. Without a unit, that number means nothing. So we were just looking at those rulers. We don't know if those rulers were inches, meters, centimeters, kilometers. We don't know. So those numbers don't really mean much to us. We need to have a unit, and in chemistry we use SI units. Let's review what those SI units were. If we are taking the mass or the weight of something, what would its unit be? Grams or kilograms. We don't use pounds or ounces. Good. What about if we were taking the length of something in chemistry? The length or distance, what would we use?
Meters.
Meters or centimeters, that'd be perfect. And then finally, so I think I said mass and I said length. What if we were taking the volume of something? Liters or milliliters, kind of like you just practiced on your virtual lab, right? Cool, good review there. Alrighty, I have a quick question for you, and I'm not asking for an answer quite yet, maybe later on. But do you guys think you would be breaking the speed limit in a 40-mile-per-hour zone if you were traveling at 60 kilometers per hour? Keep that in the back of your mind. Let's think about it. But first, before we learn how to convert, I want to show you why it's really important to learn conversions. So I have a video to share with you about a person who is, sorry, I'm getting my my aux cord all set up here. But there's a person here that I'm going to show you who did not pay attention during their high school chemistry class when they learned about conversions, okay? So let me share this with you.
We're traveling from Logan to Boise, and I just proposed a math question to my beautiful wife, Chelsea. And the question, very difficult to calculate, is if you are traveling 80 miles per hour, how long does it take you to go 80 miles? Okay, what do you think, Chel? Let's go through the process. What do you think?
Well, if I run a mile in about 9 minutes,
Wait, what about the tire turning thing you were talking about? Do you think that affects it?
well, I'm just guesstimating probably about, it turns about 400 times in a mile.
That's just calculate, like guessing calculations.
Yeah, I don't know how you work that out.
It'll be tough.
Yeah, so, I don't know. Because if I run a mile in like 9 minutes, then, I mean, but that's when I'm out of shape. When I'm really in shape, at like 7 minutes is when I'm like really in shape. And that takes me a mile. And we're going 80 miles. I'm running in about probably 10 miles per hour, if that.
Yeah.
And that's pretty fast for a human being, I think. But, I mean, it's gotta take at least like 58 minutes or something
58 minutes? It's pretty close.
to go 80 miles.
Do you want to know what the answer is?
But,
Think about 80 miles per hour.
yeah.
So how long does it take me to go 80 miles if I'm traveling 80
You're
miles
driving
per
fast.
hour?
You are driving faster than a minute a mile.
Yeah, totally.
So, I would whack 80 in half, and that's 40. Because, I mean, you're probably going 2 minutes a mile.
Just whack it in half.
Well, depends on, I mean, sometimes tires turn faster than others.
Yeah, definitely affects it.
Because, I mean, I think a truck probably is slower because it weighs more.
Mm-hmm.
But I think it also matters if your car's a stick or automatic.
Okay, Chel,
What?
think about the term miles per hour.
MPH.
MPH. So if I say I'm driving 80 miles per hour, that means I'm going to go 80 miles in an hour.
No, you are not. Because you are driving faster than a mile a minute. I can run 1 mile in 7 minutes. And that's a 10. Okay? So, I mean, that's booking it too.
Okay, so if I'm going 60 miles per hour,
Then you're probably
trying to explain the answer, but
Well, you are not making sense because I make sense. You do not make sense. My car's tires may be a little, they're kind of a little flat, so they may not move as fast as like a police officer's tires that are full. But I just,
okay, Chelsea,
my
answer.
tires are turning maybe I'd say about 400 times per mile.
Okay, I'm gonna tell you the answer. You ready for the
No, they
answer?
gotta be like 1,000.
You ready for the answer? The answer
You
to
don't know the answer.
I do know the
You
answer.
can guesstimate just like I guesstimate.
Not guesstimating. I'm using math, science. I'm using my own. I'm using my own term. Okay, Chel. The answer to the question, how far? No. How? How long does it take me to travel 80 miles if I'm driving 80 miles per hour? The answer is 1 hour. Your guess was close.
So say you drive 60 miles per hour at 60 miles.
For
You want to go 60 miles at 60 miles per hour. Is that an hour?
Yep.
What about 40 miles at 40 miles per hour?
Then you will go 40 miles
No,
in
you
1 hour.
don't. You cut that in half. There's a lot more than a mile a minute. Okay, what's the time?
All right, shield your eyes. 3, 2, 1.
He's not filming.
So Chelsea here. Chelsea had a hard time with conversions. You may have figured out what the answer to that problem was. We're going to continue on from now. We'll come back, okay? I have a challenge for you. I'm going to give you about 60 seconds now, and I want you to figure out, you can work with your shoulder partner if you want, but I want you to try and figure out about how old you are in minutes, okay? You can use a calculator, you can work it out, you can write it out, do whatever you need to. Take about 60 seconds. How many minutes are in a day? Okay, I'll give you about 10 more seconds.
Oh, that's nice.
That's a lot of minutes. Alrighty. Give me a thumbs up if you think you got it. Okay, I'm seeing some thumbs. Okay. So, I know we do have some different ages in here, but I'm just going to go with about 16. That's usually the average age of my students. Let's assume you're about 16 years old. Is anyone willing to kind of walk me through what you did? Gage.
Okay, so what I did actually went a tiny bit more in depth than just basic conversion.
Okay.
What I did was, hold on, let me started it. So basically, what I did was I took my age minus 1,
Okay.
then I multiplied that by 12 to find out how many months I've been alive.
Okay. So from years to months. Okay.
And then I added like the extra months since my last birthday.
Okay.
Then what I did was I multiplied it by about 30 since there really isn't time to go like, oh, this many 28-day months.
Okay.
30-day months.
So about from years to months and months to about days. Alrighty.
So now that we're at days, I subtracted a little bit just to get about right. Then I multiplied it by 24 to go into hours.
So from days to hours.
Then I multiplied that by 60 to get
hours to minutes. Cool. That's pretty close to what I would have done. We'll say, let's start with, or I'll just kind of work out. I'll show the work for a little bit close to what Gage did. I'm going to cut off the months and I'm going to go from years to days because I think I know about how many days are in a year. So let's start with about 16. 16 years, time sign line, and I'm just kind of setting up your first conversion problem here. Do we know a conversion from years to days? Yeah, we do. How many days are in 1 year? Good. So in 1 year, there's about 365 days. And then we can go from days to hours, right? I don't know what the conversion is from days to minutes, but I do know days to hours. So in 1 day, about how many hours are there? About 24 hours. And do we know a conversion from hours to minutes? Yeah. So in 1 hour, there's about how many minutes? 60 minutes. Very good. You can type all that in your calculator as 16 times 365 times 24 times 60. Since all of this is over 1, do you actually need to divide by anything? Nah, it's over 1, so you can kind of leave that out. And if you were about 16 years old, about how many minutes have you been alive? 8,409,600 minutes. Some of you might have gotten a little bit less. Some of you might have gotten a little bit more. But my goodness, that's a lot of minutes. That's a lot of minutes, isn't it? Okay, I'm going to come back to this work, but we're going to pick up the pace a little bit because we only have 15 minutes remaining in class. Alrighty, when we are doing conversion factors, just like always, I like to define what we're talking about here. So a conversion factor is a ratio of equivalent units. You guys told me, I know there's 365 days in 1 year. 1 year and 365 days are equivalent, right? 24 hours and 1 day equivalent. Following? Okay? Those are always equal to 1, meaning that they will always cancel each other out. So 365 days over here, 1 year over here, they're always the same thing. They have the same value. So kind of what I was just saying here, when multiplying by a conversion factor, the numerical value might change, but the actual size of the quantity remains the same. So one example I have is, do you guys know how many pennies are in $1? 100 pennies. 100 pennies in $1. If I'm holding 100 pennies in this hand, and I have $1 in this hand, I've got a whole lot more over here than I do in this hand, right? But is the overall quantity the same? They're both equal to $1. 100 pennies, $1, both equal the same thing. The number might be the same, 100 versus 1. The number is the same, but the actual quantity, the number is different, but the actual quantity is the same. I'm going to keep moving forward. When working with conversion factors, we use what is called the factor label method. I have a feeling you'll pick this up really quickly, but I'll tell you here real fast. The factor is the number that explains the relationship between two things. So when I was talking about 100 pennies, the factor would be 100. That's the number. The factor is the number. We're on page 8 of our notebooklets now, if you were keeping track. And the label is the unit. So 100 was the factor, pennies was the label, or the unit. Factor is the number, label is the unit. I'm going to show you some examples when you're ready, so if you've got that down, look up. Okay, see lots of faces looking at me. One example I've got here is 4 quarters is equal to $1. Looking at just this side, what's our factor? 4. The factor is the number. Then what's our label? Quarters. Very good. What about on this side? What's our factor? 1. What's our label? $1. Cool. So 4 quarters equals $1, but $1 equals 4 quarters. So again, the 1 would be our factor, the dollar or the quarter would be our label. You don't have to write this down as exactly as I wrote it. If you're picking this up, that's okay. Another example here, 12 months is the same as 1 year. 1 year is the same as 12 months. Or 1 foot is the same as 12 inches. 12 inches, the same as 1 foot. Right? You know those from your life experience, don't you? That's pretty cool. You know a lot about chemistry before you came in here. Now, before I go on, though, I want to make sure that we talk about rules, and I'm going to give you some reasons to use this, okay? So, let me give you our 3 rules. The first rule, and you probably did this when I asked you the question about your age in minutes, the first rule is that you always write what you know. When Gage described his process for figuring out his age in minutes, he started with how old he was. You know that. Start with what you know. Then, multiply by a conversion factor so that the units cancel out. Whatever number or unit is in the numerator, the next set needs to be in the denominator. I'm going to show you what that looks like. I know that wasn't very clear. Continue converting until your answer is in the desired units. What was the desired unit for that question about your age? Minutes. So we kept converting all the way until we had our age in minutes. Start by writing what you know. Multiply by a conversion factor so that you cancel out all of your units, and make sure you finish in whatever the question's asking for. So let me give you an example. We have your age in minutes. First thing we always do is start by writing what we know. We knew what? Knew we were 16 or 15 or 17. And then cancel out all of your units. Make sure you finish with whatever the question was asking. So here's how I did my work. I started with 16 years. From 16 years, I converted to days. Years on top, and followed by years on bottom, cancels out years. Does that make sense? Okay. Then we were in days. Days on top, followed by days on hours, and days on bottom and hours on top, means we can cancel out days. We can go then from hours to minutes. Cancel out hours, we're left with minutes. We got an answer of about 8,409,600 minutes. That's a long time. Again, our checklist was we started with what we knew, we canceled out our units, and we finished in whatever the question was asking for. In this case, it was minutes. Coolio? Yeah? Awesome. Let me talk about, I'm gonna get kind of sarcastic for a second because it's funny. So let me give you Miss Lenard's top 4 reasons to not use the factor label method. Are you ready? The first of those reasons is that you're super intelligent and enjoy solving relatively simple problems in the most complex manner. Number 2 reason to not use the factor label method would be because you're tired of always getting the correct answer. Don't you just hate when that happens? Number 3 is you're artistic, and rather than using Miss L's concrete sequential method of solving problems, you want to use your own random method such that you create an abstract pattern and design on papers so that you might be able to sell them as artwork. That's a possibility. And finally, number 4 here. Let's say you have no interest in knowledge and you don't mind being unhappy, insecure, uninformed, and overall unpleasant. Otherwise, you should use the factor label method. Have I convinced you? Maybe not quite. I have some testimonials. Here we go. All right. Here's the first of the 2 testimonials I have. I was a BLHS student who dozed off while Miss L taught the factor label method in chemistry. I never quite got the hang of it. It irritated me, all of those fractions. I never really liked fractions. Although my grades have been pretty high, I got a D in chemistry and subsequently did not take any more high school science classes. It was not long before I started on drugs and then used crime to support my drug habit. I recently learned the factor label method and realized how simply it could have solved all of my problems. Alas, it is too late and I won't get out of prison until 2022. Even then, my self-image is permanently damaged. I attribute all of my problems to my unwillingness to learn the factor label method. From Jane. Wow, guys, don't be like Jane. I've got one from Bill here. Bill says, I thought I never knew anything and that I thought I knew everything and that sports was the only thing that mattered in my high school career. When Miss L taught our class the factor label method, I didn't care about it at all. I was making plans for the weekend with my girlfriend who loved me because I was a running back and not because of chemistry. While other kids were home solving conversion problems, I was practicing making end sweeps. Then one day, I was hit hard. Splat, my knee was gone. I was a total loser. My girlfriend deserted me. My parents, who used to brag about my football stats, stopped loving me and started getting on my case about grades. I decided to throw myself into schoolwork, but I couldn't understand anything. I would get wrong answers all the time. I now realize that my failure in school came from never having learned the factor label method. I thought everyone else was smarter than me. After the constant humiliation of failing, I finally gave up. I'm worthless. I have no friends, no skills, no interests. I have now learned the factor label method, but it is too late, says Bill. Oh, man. Have I convinced you now? Maybe. All right, let's do an example. How many quarters do you have if you... I'm sorry, I can never read these correctly. How many dollars do you have if you have 38 quarters? Always start with what? What you know. We know 38 quarters. And what are we looking for? Dollars. Very good. Start by writing what you know. We know 38 quarters. I'm going to label these QT. Time sign line. From quarters, do we know a conversion directly from quarters to dollars? Yes, we do. What is the conversion there? 4 quarters equals how much? $1. Okay. So, if I want to get rid of quarters, that has to go in the denominator. I'm headed towards dollars. That's what I want my final answer in. It will go on top. You said 4 quarters is equal to $1. Are we in the desired unit? Yeah. We can cancel out quarters. We're left with dollars. Type into your calculator 38 times 1 divided by 4. Tell me what you get. 9.5. Very good. $9.50. That's not too bad, is it? Let's do another one. This one's going to be a little bit more advanced, and we only have a few minutes left, so stick with me, okay? This is probably the last example I'm going to get to today. All right, example number 3 asks, how many nanoseconds are in 1 week? I'm going to give you a secret here. I will tell you that 1 nanosecond is equal to 1 times 10 to the negative 9th seconds. So there's our conversion. Now, what do we know from our problem? What do we know here? What do we know? 1 week. We know 1 week. What are we looking for? Nanoseconds. All right, we know 1 week. I'm going to start by writing 1 week. Time sign line. Do we know how to get from weeks to nanoseconds? No. But where can we go next? Days. We can go from weeks to days. So where do we put weeks? Top or bottom? Bottom, we want to get rid of it. Very good. And what's going to go on top? Days. So 1 week, 1 is the factor, week is the label, 7 days on top. Do we know a conversion from days to nanoseconds? No, where can we go?
Hours.
Do we know from days to hours? Yeah, we can go to hours. Days on bottom, hours on top. What's the factor there? I'm sorry, the conversion there. 1 day equals 24 hours. Make sure you're keeping your factor with the correct label. Now we're in hours. Do we know a conversion from hours to seconds? No. Do you? You might. But what's an easier one? Hours to minutes. All right, hours on top. I'm going to pick up the pace since we're almost done. Hours on top, minutes on bottom. What's the conversion here?
60.
1 hour and 60 minutes. Can we go from minutes to seconds? All righty. We'll put minutes on bottom, seconds on top. How do those relate? 1 minute and 60 seconds. And finally, we know 1 nanosecond is equal to 1 times 10 to the negative 9th seconds. So I'm going to write seconds on bottom, nanoseconds on top, 1 times 10 to the negative 9th, 1 on top. Let's make sure our units cancel out real fast. Weeks, days, hours, minutes, seconds. Left with nanoseconds. In your calculator, you would type 1 times 7 times 24 times 60 times 60 divided by, you might want to remember to put this in parentheses, 1 times 10 to the negative 9th. When you do so, you should get about this big old number down here, 6 times 10 to the 14th nanoseconds. Okay, worksheet number 2 is not homework. If you did not finish your lab, make sure you finish that and get it turned in. If you are feeling like it, I would suggest trying a couple of problems on worksheet number 2 so that you have a little bit less homework later on. Okay, it will be due eventually, just not next class. Great work today, everyone. Beautiful job.